This video, we're going to look at the review problems for chapter 6. Along with the idea of decimals comes the idea of percents. Percent means out of 100, so we can express the same number as a percent, a decimal, or fraction. We're going to use that to our advantage here. So going to convert 14 7/10% first to a fraction. So we're going to say that that's 14 7/10 over 100 because percent means out of 100, but we don't put decimals inside of fractions. So we need to shift the decimal one place to the right in the numerator. So we have to do the same in the bottom, and that's the same as 147 thousandths. There are no common factors. Let's prove that to ourselves though. This is 7 times 7 times 3 in the numerator, and the denominator is 10 to the third. So it's 2 to the third times 5 to the third. So I see no common factors. All right. Now we're going to instead write it as a decimal. So that should be easy enough to read. 147 thousandths is 147 thousandths, like that. This was number 44. Number 45 asks us 63 is 35% of what number? So we're going to set this up like an equation. The verb is our equal sign. So 63 is p%. So 35% of always means to multiply. And the question word is our variable. So I'm going to set it up like that. We're going to multiply by the reciprocal of this fraction. If you want to do that in 2 steps, you can do that. And so let's start reducing here. That 5 goes into 35 7 times. 5 goes into 120 times. 7 goes into 63 9 times. And 9 times 20 is going to be the same as x. So x is going to be equal to 180. Moving on to problem number 46. Nutrition label on a package of granola bars says that each granola bar has 180 calories and 81 calories are from fat. What percentage of the calories are from fat? So there's 81 calories from fat divided by 180 calories total. We're going to change that to a percentage. So there's really no need to simplify here, though we can. We can say that this is the same thing as 9 over 20. And if I would multiply now by 5 over 5, that's 45 over 100, which is 45%. This is just one way you can do it. You can try and make the denominator 100 when you can do that easily and just read it as a percent. But most of the time, what we're going to do is we're going to use long division here. And we're going to say that this is 180 into 800. It's probably about 4 times because this is about 200 and this is about 800. So that's just a good estimate. We're going to subtract and get 90. And then we're going to go one more because 720 plus 180 is 900 exactly. So 5 times 180 is 900. We get our 45 hundredths, or we change that into a percentage by multiplying by 100% is 45%. Again, you hear the cent and percent. Think of it like in dollars and cents. How many cents is here? 45. So go 47. Elliott receives $510 commission when he sold $3,400 painting, a $3,400 painting at the art gallery that he works with. What was his commission? So he received $510 for a painting that was worth $3,400. So we need to divide. The first thing that I can do to make life easier for me is divide numerator and denominator by 10. Okay. And now I can start dividing with long division. This is only going to go in one time. And then that looks like that might go in 5 times. And his commission is going to be 15%. Nandita bought a set of towels on sale for $67.50. The original price was $90. What was the discount rate? So the discount rate is going to be the difference in price divided by the original price. So we need to, let's just look at our markup or markdown. So our markdown, our sale price is equal to our original price minus our markdown percentage times our original price. So if we want to solve for our markdown percentage, we can take our difference between our sale price and our original price. Let's just switch sides here. That our markdown percentage times our original price. Moving that negative part to the left, going to be equal to our original price minus our sale price. And then we're going to divide by our original price to get our markdown percentage. Now that's going to be expressed as a decimal, so we're going to need to change it to a percent at the end. So it's going to be original price minus our sale price divided by our original price. We're going to have to multiply by 100% here to change it to a percent. So let's do that. Here's our formula here. Original price was $90. Our sale price was $67.50. We're going to divide that by $90 is going to, and then we're going to multiply by 100%. So our numerator here is going to be $22.50. The denominator is going to be 90. Okay, So let's do some division off to the side over here. And this is going to go in twice. And this is going to go in 5 times. So our markdown percentage is 25% off. Alan invested $23,000 in a friend's business in 5 years. The friend has paid him the $23,000 plus $9,200 simple interest. What is the rate of simple interest per year? Okay, so I is equal to PRT. So I, let's solve for R, the interest rate. I divided by PT is equal to R. So R is going to be equal to the interest, $9,200, divided by the principal, which was $23,000, times the time, which was 5 years. And we're going to have to multiply that by 100%. So we're going to have a lot of zeros that are going to cancel off here. Got a couple of zeros cancel off. So this is 92, 1,150 times 100%. So I think this is 8 here. 40, 12, 9. So it is an 8% interest rate. Then the last problem here for this section, problem 50, asks us to solve 9 over P is equal to -6 over 14. We're going to solve this as a proportion. We're going to say that 9 times 14 is equal to -6P. It's 36. 12. I'm going to divide both sides by -6. We're going to get that P is equal to -21. P does not necessarily represent a percent here, but one of the ways that we can find percents is to say in a percent problem like number 45, that if I say A is P% of B, like that, that A over B equals P over 100. And we can set it up with the proportion like this, where A is your amount that you have, B is your base, P is your percent, and whichever one of those is missing in the problem, you can set it up like this. Okay, that's it for this video. Next time we'll come back and talk about properties of real numbers.